Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. Okay, so let us move on to the next topic, which are the modes of the transistor of class 12 chapter 14 Semiconductor Electronics, Materials, Devices and Circuits. Okay, so let us move on to the modes. So basically transistor works in 4 modes. The 4 modes are forward active, reverse active, saturation and the cutoff mode. So we all know that the transistor was invented by J. Bardeen and W. H. Brattain in the Bell Laboratories. So after the invention, the modes were discovered. The modes were discovered of the transistor. So how the transistor works, what all are the modes of the transistor. So the first mode is the forward active mode. Now these modes can be understood taking any of the configurations. The configuration which I have taken over here is the common base configuration, and the type of transistor I have taken is the Npn transistor. We can take any of the transistor and understand the modes of the transistor. Okay, so here we have taken the common base transistors. Everywhere we have taken the common base transistors, in which there is the base which is common. And we have taken the NPN transistor. We can also take the PNP transistor. It hardly matters. Okay, so here we have taken the NPN transistors in order to understand. And NPN transistor, we already know, is a transistor in which a P-type semiconductor is sandwiched between 2 N-type semiconductors. So the first mode is the forward active mode. So in the first mode, why it is known as the forward active mode? In the forward active mode, it is known as because in this mode, this region, this is the region between the emitter and the base. The emitter and the base region. This region is forward biased in this type of mode, and the collector to base region is the reverse biased, and the collector to the base region is the reverse biased. Okay. So when this region is forward biased, my electrons can easily move through this region. Okay, but here my electrons cannot move. So this type of mode is used basically for the amplification of the signals. It is used. Okay, so forward active mode is used for the amplification. Okay, so when my base to emitter region is in the forward bias state, so my base to emitter voltage will be positive. So if I have to represent it in the XY coordinate system, then I can represent this to be positive over here. Okay, and my collector to base voltage is negative, because this region, collector base region, is reverse biased. So collector to base voltage is negative. Okay, because my collector to base region is reverse biased. So this voltage is negative. So this voltage negative can be shown on the y-axis, which is this axis. So the quadrant in which the forward active mode lies is the fourth quadrant. Okay. So this was my first mode of transistor. Now let us move on to the second mode. The second mode is just reverse of this mode, as the name suggests, reverse active mode. So it is the just reverse of the forward active mode. In the forward active mode, my base to emitter region was collected in the forward bias, but in the reverse active mode, my base to emitter region will be connected to the reverse bias condition, because N is connected to the positive terminal of the battery. It is connected to the positive terminal of battery, which makes it reverse biased. And here my collector to base voltage was negative. Why it was negative? Because my collector to base region was reverse biased, but it is just reverse over here in the reverse active mode. In the reverse active mode, my collector to base voltage is positive, and my collector to base region is in the forward biased. Okay, so this type of, if the connections are made to the transistor, then they come in the reverse active region. Okay, then the third type of mode is the saturation mode. It is the saturation mode. So what is in the saturation mode? In the saturation mode, both the type of regions are collected in the forward bias mode. They both are connected in the forward bias mode. My VBE is also connected in the forward biased mode, as well as my VCB is also connected in the forward biased mode. So when my N-type semiconductor is connected here with the negative terminal, it becomes the forward bias mode, and the base to emitter region is forward biased, is said to be as forward biased. And also when my collector to base region is, when my here collector N-type semiconductor, collector is N-type semiconductor, so it is connected to the negative terminal of the battery, then again it forms the the forward biased, then again it forms the forward bias. So in the saturation region, both of my regions will be connected to the forward bias mode. Now when my N-type semiconductor is connected to the negative terminal of the battery, my electrons can easily move through here, and they can easily move to the base over here. My electrons can start moving over here, and they can constitute a current over here, and they can move to the base. Similarly, from here also my electrons can easily move, because the electrons will be attracted with move along the electrons of this region, and they will also constitute a current, and they will start moving, and they will move towards the base. So in the base a large current will flow. So in this mode, my transistor basically works as a closed switch. Okay. So for making my transistor to work in a switch, to making my transistor to work as a switch, it has to be connected in the saturation mode. And it behaves as a closed switch. So I can write over here, it behaves as a closed switch. Okay. Now the last mode is the cutoff mode. In the cutoff mode, both the regions are connected to the reverse bias condition. Means that N-type of semiconductors of emitter is connected to the positive terminal of the battery. Also the N-type semiconductor of the collector is connected to the positive terminal of the battery. So both of the regions are the reverse biased, and both the voltages are negative. Both the reverse bias means negative. So my VBE as well as my VCB, both are negative, and so the cutoff region is denoted in the third quadrant. Saturation mode is in the first quadrant, reverse active is in the second quadrant, cutoff mode is in the third quadrant, and the forward active is in the fourth quadrant. So in the cutoff mode, my both the voltages are denoted in the third quadrant, and both the voltages are negative because both the regions are reverse biased in the reverse bias condition. Both the regions are in the reverse bias conditions. So in this mode, when my electrons will not be able to move so comfortably over here because they are connected in the opposite direction. So from here all the electrons will start moving and will be attracted towards this positive terminal, and also from here all the electrons will be moving straight away from here and will be start moving towards this positive terminal. Okay, so in this situation my transistor works as an open switch. So in order to make my transistor working as a open switch, my transistor should be connected in the cutoff region, So in this situation also my transistor works as a switch, and that too open switch, and here in the first mode, which is the forward active mode, it works as an amplifier. So this is the best suitable mode for the transistor to work as an amplifier. So basically from these modes we can conclude that our transistor has got two applications. The first application is working as an amplifier. So for my transistor to be working as an amplifier, it should be connected in the forward active mode. And secondly, my transistor works as a switch, and to work the transistor as a closed switch, the transistor should be operated in the saturation mode. And in order to work the transistor as an open switch, in open switch mode, it should be connected in the cutoff mode. So these were the all 4 modes which were discussed in this video. So please share my videos, please subscribe my channel, and if you have any doubt, you can ask me in the comment section. Thank you.